Hello. Till now we have studied a number of properties of an AP, and in the last class we also studied how to calculate the nth term of any AP. In this class we are going to study one more thing about AP, that is how to calculate the sum of n number of terms of an AP. And then we'll also study how do we use this concept of sum of n terms to solve different kinds of problems. So consider this example of an AP. Here the first term is 150 and the common difference is 50, which means the second term will become 200, third term will become 250 and so on. You already know the formula for calculating the nth term of any AP, so you can find out as many number of terms of this AP as required. But let's say I ask you to calculate the sum of first 10 terms of this AP. Then it will be very difficult for you to find out the 10 terms first and then individually add them up to get the sum. So in order to solve this problem for us, we are going to try to find out a formula for calculating the sum of any n terms of an AP. This formula will help us save our time and calculate the sum easily. Now let's try to understand how to calculate the sum of n terms of an AP. Before doing that for any AP, let's take a simple case. Here I have my first term as 1 and the common difference is also 1. So this simply becomes a counting series, that is 1, 2, 3, 4 and so on. I have written it up till 100, that means I have taken 100 terms. If I want to calculate their sum, I'll simply write 1 plus 2 plus 3 plus and so on up till 100. Even if I reverse these terms, reverse the order of these terms, the sum would remain the same. Because a plus b or b plus a, it does not matter, the sum remains the same. So I can also write this as 100 plus 99 plus 98 and so on, and in the end it will come 3 plus 2 plus 1. If I add these two, what will I get? I'll get twice of the sum, that is 2s. If I add the individual pairs of these terms, I will get 100 plus 101, 99 plus 201, 98 plus 301. Observe carefully that every pair of terms gives me 101. Even towards the end, 98 plus 3 again 101, 99 plus 2 again 101, 100 plus 1 again 101. So basically I would get 101 100 times because I had 100 terms initially, so these pairs would also have been 100. Simply put, twice of the sum is 101 into 100. That means my sum is 101 into 100 divided by 2, and that means the sum is 5050. Now let's take this procedure and calculate the sum for any AP in the general form. Now let's try to calculate the sum for a general AP. Here I have written an AP in general form where my terms are a plus d, a plus 2d and so on. So my nth term will become a plus n minus 1 into d. To calculate the sum, I'll add all these terms together. Then even if I reverse these terms and then add, my sum would remain the same. So again, Sn can also be written as the last term first, a plus n minus 1 into d. Then the term before that next, a plus n minus 2 into d. Towards the end, I'll get a plus d and then a. Again, if I add these individual pair of terms together, I'll get the sum of the whole equation. On the left hand side, I'll get Sn plus Sn, that is twice Sn. On the right hand side, let's see what happens. If I add a and a plus n minus 1 into d, I'll get a plus a 2a and then n minus 1 into d. The next pair of terms, what will it give me? I have a plus d and a plus n minus 2 into d. So again, a plus a will give me 2a and d plus n minus 2 into d will give me n minus 1 into d. Again, what is happening here? This same term, 2a plus n minus 1 into d is getting repeated again and again. And how many times is it getting repeated? It is getting repeated n times. Why? Because I had taken n terms initially. So these pairs of terms would also be n in number. So basically twice of Sn is this term repeated n times. So I can multiply it to get the answer. So I will get n into 2a plus n minus 1 into d. So I can get a simple answer for Sn, which will be n by 2 into 2a plus n minus 1 into d. This is my formula for calculating the sum of n terms of an AP, and I can use it to solve various different problems.